In this presentation, we will explore the concepts of data masking and data obfuscation. These are techniques used to protect sensitive information while ensuring that the data remains functional for various purposes such as testing, development, and analytics. Let's understand how we can safeguard valuable data assets in a world where data privacy is paramount. Let's define what we mean by data masking and data obfuscation. Data masking is the process of hiding original data with modified content. It preserves the data format and integrity, ensuring that the masked data can still be used in a similar way as the original. It also maintains referential integrity across databases, which means that relationships between different pieces of data remain consistent. Data masking is commonly used for testing environments where real data is not needed, but the structure and format are important. Data obfuscation, on the other hand, scrambles sensitive data to make it unintelligible. This creates structurally similar but inauthentic data, protecting against unauthorized access. Data obfuscation also helps comply with data privacy regulations by making it difficult to reverse engineer the original data. There are several techniques used for data masking. Let's explore some of the most common ones. First, we have substitution. This involves replacing original values with fictional, but realistic data from predefined lookup tables. For example, the name John Smith might be replaced with Alex Johnson. This ensures that the masked data is still realistic and can be used for testing purposes. Next is shuffling. Shuffling rearranges values within a column, maintaining the overall distribution of the data, but breaking any direct associations. For instance, if user 1 originally had $5,000 and user 2 had $3,200, after shuffling, user 1 might have $3,200, and user 2 might have $5,000. The amounts are the same, but the association with the users is broken. Lastly, encryption transforms data using algorithms that can be reversed with the proper key. This method is useful when the masked data needs to be converted back to its original form. For example, a phone number like 555-123-4567 can be encrypted into a string of characters like XC7, $PQ9 at symbol RT3 MZ2. Here are some additional data masking techniques. Nulling out involves replacing sensitive data with null values when the data isn't needed for testing or other non-production purposes. For example, a social security number could be replaced with the value null. Masking out replaces portions of data with masked characters such as X's or asterisks, while preserving the original format. This is useful for redacting parts of a credit card number or social security number. For example, the credit card number 4111-2222-3333-4444 could be masked as 4111-XXXX-XXXX-4444. Finally, tokenization substitutes sensitive data with non-sensitive placeholder values, or tokens, that map back to the original data. This allows you to use the tokens in place of the real data without exposing the sensitive information. For example, a credit card number could be replaced with a token like token_7890. Let's look at some practical examples of implementing data masking in Python. First is a credit card masking example. We define a function called maskCreditCard that takes a credit card number as input. If the card number has fewer than 8 digits, we simply return the original number. Otherwise, we keep the first 4 and last 4 digits and mask the rest with X's. Finally, we return the masked credit card number. As an example, if the input is 4111-2222-3333-4444, the output will be 4111-XXXX-XXXX-4444. In email address obfuscation, we define a function called obfuscateEmail that takes an email address as input. We split the email into username and domain. If the email does not contain exactly 1 at symbol, we return the original email. Otherwise, we show the first 2 characters of the username and replace the rest with asterisks. For example, if the input is john.doe@example.com, the output will be jo3*@example.com. Let's see how data masking looks in practice with a before and after example. In the original customer data table, we have columns for customer ID, full name, email, credit card, and social security number. The table contains real and sensitive information. Now, in the masked customer data table, we have applied various masking techniques to protect the sensitive information. For example, John Smith is replaced with Alex Wilson. John.Smith@example.com becomes jo3*@example.com. The credit card number is partially masked, and the social security number is also masked. It's important to note that different masking techniques are applied based on data sensitivity and requirements. While data masking is a powerful tool, there are challenges to overcome. Maintaining referential integrity, which refers to the relationships between data in different tables, can be challenging. To solve this, use consistent masking algorithms across related tables and preserve foreign key relationships. Another challenge is maintaining data realism. Masked data should remain realistic enough for proper testing while being sufficiently anonymized. The solution here is to use domain-specific masking techniques that preserve data characteristics and distributions. There is also a performance impact because masking large data sets can significantly impact system performance and processing time. In this case, implement incremental masking, parallel processing, and optimize algorithms for large data sets. Regulatory compliance is also very important because different regulations, such as GDPR, HIPAA, and CCPA, have varying requirements for data protection. To adhere to this, implement configurable masking policies that can be adjusted based on specific regulatory requirements. To summarize, data masking and obfuscation are essential components of a comprehensive data security strategy. Data masking protects sensitive information while maintaining functionality for testing and development. Multiple techniques can be combined to achieve the right balance of security and data utility. Regulatory compliance often requires data masking as part of a comprehensive data protection strategy. Implementing data masking early in the development lifecycle helps prevent data breaches. For further learning, you can refer to NIST guidelines for data protection, OWASP data masking cheat sheet, and industry-specific compliance frameworks. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.